Okay, in this video I'm looking at partial fractions again, but what happens when you've got a repeated factor in the denominator. So if you look at this, you've got x plus 1 squared times by 2x plus 1. So the repeated factor there is x plus 1, okay, because it's squared. Now, just take a moment to think about what form you think the partial fractions will take. So, what do you reckon? Now, I'll tell you what the most common response is, for those people who have not seen it before. The most common response is this: a over x plus 1 plus b over x plus 1 plus c over 2x plus 1. I'll tell you why it's the most common response. It's wrong, by the way, because that is just x plus 1 times x plus 1, isn't it? So you can write as x plus 1, 2x plus 1. Okay, so you might think x plus 1, 2x plus 1, but no. One answer I'll give you is this. What is the least common denominator of this? The least common denominator is not that, is it? Okay, it's x plus 1, 2x plus 1. Because you could actually combine these two fractions here, you see, as a plus b over x plus 1. And the a plus b is just another constant. You may as well call it something else. And I like d over x plus 1. Okay, so what you've ended up with really is just two partial fractions there. And of course, you can see that that is not going to be the same as that. So that's incorrect. Okay. Let me tell you another common mistake. Okay, so some people mistakenly think it's this. I'll write it down here: a over x plus 1 squared plus b over 2x plus 1. And you can see why. Again, people might think that because this time the lowest common denominator is actually that, isn't it? So if you combine these together, you would get that as your denominator. However, the correct form of partial fractions is actually this, when you have the linear term there, but then x plus 1 squared, 2x plus 1. Why is that the case? Because what you're missing out on is the potential to have a linear term involving x plus 1. Because if you think about it, the lowest common denominator of these three is still that. Okay, so if you don't include this term here, you're missing out on the potential case that you might have a linear term of x plus 1 on the bottom. Okay, so I'm going to rub this out and I'm going to keep that as the correct partial fractions form. In short, in general, what you're doing with the beta factor is you just have it as the linear term, the x plus 1, and then the square term, x plus 1 squared, and then of course the 2x plus 1. So we're going to go with that. And then from then on, the method is exactly the same as before. So what we're going to do is multiply both sides by the denominator here, x plus 1 squared, 2x plus 1. Just bear in mind what I've been saying in these videos, it's difficult to squeeze it all in, so I'm going to scrunch it all up again to try and get it all on. So the left hand side will be 11x squared plus 14x plus 5, and then the right hand side, remember we're multiplying both sides by x plus 1 squared, 2x plus 1. So this term, one of the x plus 1's will cancel, and we're left with an additional x plus 1 and the 2x plus 1. So that would be a x plus 1, 2x plus 1. Okay, and then the next term, we're multiplying by x plus 1 squared, don't forget, so the x plus 1 squared will cancel. You're just left with the 2x plus 1, so 2x plus 1. And then the last term, the 2x plus 1's will cancel, and you'll be left with the x plus 1 squared. So there we go. I did say it's a bit of a squeeze. There we go. That's the only thing I don't like about the three different partial fractions, just trying to get it, because I love having everything on one line. I hate doing the stupid thing where you kind of can't fit it on and then you just do the next. It just doesn't look right, does it? Okay. Right, next, what we're going to do? Well, we're going to substitute values in. Always the preferred method. Okay, remember there is the second method, method 2, of expanding the brackets and equating coefficients of x squared, x and so on. But the thing is you end up with simultaneous equations, it's a bit longer. Always best to try and use substitution as much as possible, okay? So the first sensible value to choose would be x is negative 1, yeah? Because then those two terms will cancel. So on the left hand side, let's write down here, we'll have 11 times negative 1 squared, so that's 11, and then that will be subtract 14 plus 5. So what's that? 16, subtract 14, that's 2, okay? And on the right hand side, we'll have 0, and then this here, negative 2 plus 1, so that's negative 1, b, so negative b, and that's 0 of course. So that gives us quite nicely b is equal to -2. Okay, first one done. The next value of x to substitute in is going to be -1/2. So x is equal to -1/2, and on the left hand side, -1/2 squared is 1/4, so 11 quarters. Okay, we'll see how this goes. 14 times -1/2 is going to be -7 plus 5. Okay, let's simplify that. So 11 over 4, -7 plus 5 is -2. And then 11 over 4, subtract 8 over 4, so that's going to be 3 over 4. Right, so the left hand side then, 3 over 4. And on the right hand side, that will be 0 of course, that will be 0. -1/2 plus 1 is 1/2. Square that, that's 1/4, so 1/4 c. Oh, it's not too bad actually in the end, is it? Okay, not too bad because they're both quarters on the left and the right hand side, so that means c is just going to be 3. Okay, done. And then notice now we've run out of values of x to substitute in such that one of the terms or more will disappear, okay? Because to make that term disappear, you need x equals -1 or -1/2. To make that term disappear, x is -1/2. To make that term disappear, x is -1. We've used those already, okay? So what I'm saying is you can't substitute in another nice value of x in order for one of these terms to disappear. You can continue to substitute values in, okay? Remember, the identity symbol means whatever value of x you substitute in, doesn't matter what it is, you get the same on the left as you on the right. So my recommendation is you substitute in x equals 0. That'd be nice and simple, you see. So if we do that, on the left hand side, you've got 5. And on the right hand side, we'll have 1 times 1, a, so just a. And then 1 times b, so that's going to be plus b. And then 1 squared is 1 times by c plus c. Okay, so 5 equals a plus b plus c. In other words, 5 is equal to a, we don't know, b is -2, c is 3. Okay, so 3 subtract 2 is 1, put it over to that side, so a is equal to 4. And then we're done. Okay, then we're done. Let's just write down the final answer. So the partial fractions will be a over x plus 1, so 4 over x plus 1, and then b over that, so b is -2, so subtract 2 over x plus 1 squared, and then c over 2x plus 1, so plus 3 over 2x plus 1. Okay, there we go. Job done. Okay, hoping that you found that helpful. Okay, so my next example with a repeated factor in the denominator. Now the reason I've chosen this is because I mentioned in a previous video, the textbook I'm using does this annoying thing of introducing a topic and then just going to a different example. So the way my textbook uses this example is kind of as a throwaway. It basically says you can write this as partial fractions, but we're not going to do that. We're going to go and do a different example. It kind of just leaves it hanging there, and that annoys me so much. Why bother put a math question out there if you don't go ahead and solve it, answer it? Okay, so that's why I want to do this. Okay, so I've not seen it before. Just I'd like to do it. Okay, so the partial fractions, of course, will be of this form: a over x minus 5, and then plus b over the linear of this one, x plus 3, and then c over the quadratic bit, x plus 3 squared. Okay, that's kind of how the textbook leaves it. Basically says you can write it like this, and then it's like, well, let's move on to something else. Okay, let's just work through it. Okay, my suspicion is that the values of a, b, and c are going to be less than desirable numbers, we say, not integers, fractional values, but they're still numbers nonetheless. Let's work through it. So multiply both sides by that denominator. So on the left hand side, 2x plus 9. Notice I'm squeezing it all up so that I've got enough space hopefully to write it all on. So this term will be a multiplied by x plus 3 squared. Okay, because the x minus 5s will cancel when we multiply throughout. This term will be b. One of the x plus 3s will cancel, then the other one will remain. So that will be x minus 5, x plus 3. and then the last term here, c, the x plus 3's will cancel, you're left with x minus 5. Okay, and I'm pleased again because I managed to fit it all into one line. I like when that happens. So let's just go then. So the value to substitute in will be x is negative 3, won't it? Because then that term will disappear and so will that, and we can work out c straight away. So the left hand side, so that will be negative 6 plus 9, 9 straight 6, it's 3. And on the right hand side, 0, 0, negative 3, subtract 5 is negative 8, so negative 8c. Okay, so that means c must be equal to negative 308. Okay, and that is why the textbook didn't follow it through, because for some reason they've got a fear of having fractional values for a, b and c. Why, for goodness sake, why? Year 13 maths. We can handle fractions, people. We can handle fractions, okay? Do not be scared of them. Let's keep going. X is 5 is the next one. Okay, so x is equal to 5. The left-hand side is 10 plus 9, which is 19. And the right-hand side is going to be 5 plus 3, which is 8. 8 squared, 64. So 64a. And of course 0, 0. So a is equal to 19 over 64. Oh my god, we've got another fraction. I'm going to go mad. But not really. Why would you panic? It's a fraction, okay? So if anyone panics because they get a fraction, then they're not cut out for A-level maths. Simple as that, okay? Yeah. And then we've run out of values to substitute in, such that any of these terms will disappear, kind of like the previous example I showed you. So what I'm going to do is, I'm going to either substitute in x equals 0, you could do that, or I'm going to do something a little bit different. I'm going to compare the x squared terms, okay? Coefficients of x squared. And the reason I'm going to do it is because it's quite quick and simple. On the left, there are none, 0. So you've got 0 on the left-hand side. On the right-hand side, you've got x squared times a. So you've got a. And then x squared times by b. So you've got plus b. And then you've got no x squared terms for c. Okay? So you've just got a rather simple equation there. 0 equals a plus b. Or in other words, b is equal to negative a. Hence, b is equal to negative 19 over 64. Okay, and that is it. We've worked out our values of a, b and c. Let's just complete this then. So, as I said before in the previous video, when you do have fractional values, okay, the correct way of writing it really would be to write 19 over 64, x minus 5, subtract 19 over 64, x plus 3, subtract 3 over 8, x plus 3 squared. However, the way I'm going to write it is like this. A is 19 over 64, so 19 over 64 over x minus 5. B is negative 19 over 64, so subtract 19 over 64 over x plus 3. And then C is negative 3 over 8, so subtract 3 over 8 over x plus 3 squared. And as I said, the reason I prefer that is because when it does come to doing other things with it, like binomial expansion or integration, it's often easier to have the numerator, because that often is the coefficient of the term that you end up with. Okay, so for example, that would be 19 over 64 natural log x minus 5. Okay, it's just much easier like that. Well, I hope you found that example useful. Okay. Okay, one more example with partial fractions and the repeated factor in the denominator coming up. And where's this one come from? Yes, this is another one from the same textbook where they just mention it and don't bother to answer it. It's in a watch out box earlier on in the unit. Okay, basically says watch out because these have got slightly different denominators. Okay, but then doesn't bother to go ahead and solve it or bring it up later on. I hate that. Okay. I keep on saying it, why bother pose a mathematical question if you don't answer it? Okay, there we go. So if your maths teacher in class asks to do a question and then you never ever get an answer, no point, is there? So anyway, a over x plus 4 plus b over x minus 1 plus c over x minus 1 squared. Again, I'm guessing the values of a, b and c, they're not going to be integers. Oh no! it would be fractions possibly. Okay, why don't you just pause here and have a go, see how you get on. Okay, otherwise just stick with it and stay with me. So multiply both sides by the denominator. Okay, so on the left hand side we'll get 9. On the right hand side we'll get a, the x plus 4's will cancel, and that will be x minus 1 squared, plus b, one of the x minus 1's will cancel, and you'll have x plus 4, x minus 1, and then c, the x minus 1 squares will cancel, that will be x plus 4. Okay, a bit easier to squeeze on because the left hand side is just 9, of course. So let's just substitute in x equals 1 and see what happens. On the left hand side you've just got 9, on the right hand side 0, 0, 1 plus 4 is 5, 5c, and c then is equal to 9 over 5. Oh my god, we've got a fraction, what are we going to do? Let's just give up A-level maths and go home. No, let's not. Okay, it's just, yeah, so it's just my cheap way of having a go at the textbook, because they flipping publishers put this question in and then just don't bother answering it. Okay, it's if the people actually did it, made up the question, I thought, oh no, fractions, this is going to put people off A-level maths for life, we can't possibly go over this one. Anyway, there you go. So if you don't know by now, I've got a very set sense of humour when it comes to mathematics and what people think others should be capable of and what people think others should be able to do. Okay, my own view is that if you got this far in mathematics, you should not be put off by fractions. Okay. Another variable to substitute in is x equals -4. By the way, I hope you appreciate my sense of humour. I mean, of course, if you didn't, you probably wouldn't watch these videos anymore, would you? Okay, but yeah, it's just, yeah, there's some things that, you know, some things that just need to be said. If an A-level student's got this far, they should not be scared of fractions. How many times have I said that? So many times, probably. Okay, it's just, I just don't believe that. Okay, if anyone's scared of fractions, pack up your bags, go home. Right, let's continue. So 9 on the left hand side. So -4 subtract 1, that's -5 squared is 25. So 25a. Okay, and then that'd be 0 and that'd be 0 as well. So you've got a is equal to 9 over 25. Okay, another fraction. And then what I'm going to do is I'm going to look at the coefficients of x squared again, like I did last time. Okay. You could, if you wanted to, substitute in x equals 0. That's fine. That's absolutely fine. You get 9 on the left hand side, and you get 1a, and you get -4b, and you get 4c. But you choose, you end up with 3 terms, you see. So the reason I like substituting, looking at the coefficient of x squared, because I'm only going to end up with 2 terms instead of 3. So on the left hand side, there's no x squared terms, of course. So 0 on the left. X squared times a. So that's going to be a, and x squared times b, so plus b, and of course no x squareds there. Okay, so it's got 0 equals a plus b. So kind of like in the previous example I did. Okay, you got b must be equal to -a, and so b must be -9 over 25. Okay, there we go. That's it. Done. Okay. And didn't even break out into a sweat, did we? Did you get the same answers? I really hope so. If you did, well done. You're getting the hang of this. Let's write down the final answer. So a over x plus 4, so 9 over 25 over x plus 4 plus b over x minus 1, so subtract 9 over 25 over x minus 1 plus c over x minus 1 squared, so plus 9 over 5 over x minus 1 squared, and that will do. Okay, right, that's it. I hope you found those examples helpful. Okay.